The shadow zone is a region of low sound intensity that sound waves traveling away from a source in the ocean do not reach, usually because the sound waves are refracted away from that region. The shadow zone can be exploited by submarines to avoid detection by sonar. But how can we use sonar to measure the depth and shape of the shadow zone in different locations? One way is to use a sound source and a receiver that are both located near the surface and send sound pulses at different angles. By measuring the time it takes for the sound to return to the receiver, we can calculate the distance and direction of the sound path. If there is no sound detected at a certain angle, that means the sound has entered the shadow zone and did not reach the receiver. By repeating this process at different locations, we can map out the boundaries of the shadow zone. Another way is to use a sound source that is located near the bottom of the ocean and a receiver that is located near the surface. The sound source sends sound pulses upward at different angles, and the receiver measures the time and intensity of the sound. If there is a deep sound channel in the ocean, where the sound speed is lower than in the surrounding layers, some of the sound waves will be trapped in this channel and travel long distances with little loss. This creates another shadow zone below the deep sound channel, where no sound can be detected by the receiver. By moving the receiver forward or backward, we can detect the target in the shadow zone. Using these methods, we can use sonar to measure the depth and shape of the shadow zone in different locations and learn more about how sound travels in the ocean. In this section, we will discuss some applications and challenges of studying in the shadow zone, such as exploring underwater volcanoes or detecting submarines. The shadow zone is an area of the ocean where the water is almost stagnant and very low in oxygen. It is located between two layers of water with different densities that prevent vertical mixing. The shadow zone can be found in the North Pacific and the Indian Ocean at depths of about 2 to 4 kilometers. One of the applications of studying in the shadow zone is to understand the role of underwater volcanoes in shaping the seafloor and influencing the global climate. Underwater volcanoes are sources of heat and minerals that create diverse habitats for marine life. They also emit gases such as carbon dioxide and sulfur dioxide that can affect the atmosphere and the ocean chemistry. However, studying underwater volcanoes in the shadow zone is challenging because they are difficult to access and monitor. The water pressure and temperature are very high, and the visibility is very low. The seismic signals from volcanic eruptions are also distorted by the layers of water above and below the shadow zone. Therefore, scientists need to use special instruments and vehicles that can withstand these harsh conditions and collect data from the seafloor. Another application of studying in the shadow zone is to detect submarines that may be hiding or operating in this area. The shadow zone offers a strategic advantage for submarines because it reduces the chances of being detected by sonar or other acoustic methods. The sound waves from a submarine can either reflect or refract at the boundaries of the shadow zone, making it hard to locate its position and direction. However, studying submarines in the shadow zone is also challenging because they can use various techniques to avoid detection or confuse their enemies. For example, submarines can release bubbles or decoys to create noise or false signals. They can also change their speed or depth to alter their acoustic signature. Therefore, scientists need to develop new methods and technologies that can improve the accuracy and reliability of submarine detection in the shadow zone. In conclusion, studying in the shadow zone has many applications and challenges for science and security. By exploring underwater volcanoes, we can learn more about the geology and biology of the deep ocean. By detecting submarines, we can enhance our defense and surveillance capabilities. However, Both tasks require overcoming the physical and technical difficulties of working in this remote and hostile environment.